Click the bell icon to get latest videos from Ekeeda.
Hello friends, and today we are going to study a new topic, that is time differentiation property in Fourier transform. So first of all, we'll see the statement. So if Fourier transform of x of t is represented by x of j omega, then if we are going to differentiate x of t with respect to t, or else we can say that if we want to prove a time differentiation property, then its answer or result is j omega into x of j omega. So this whole statement that we are going to prove. So first of all, we will always use a definition of a Fourier transform, and this is our hint. We will differentiate both the sets but with respect to t. So first of all, we will write the definition of Fourier transform. Now, according to statement of time differentiation property, this x of t must be differentiated with respect to t. So therefore, I am going to change this input to d by dt of x of t. So this x of t is also replaced by d by dt of x of t. Now, look at here. Let's say here I'm going to use, here the function is in product form and we don't have any formula to solve these two products. So we will use u into v rule over here, where my u is e to the power minus j omega t and my v is d by dt of x of t. So according to integration of u into v rule, first of all, v is integrated and u is considered as constant, but then we are going to integrate v, but first of all we will differentiate u and the whole result is again integrated. So we will use this formula. I'm going to substitute only u and v value in this formula. Now look at here. I have placed my u, that is e to the power j omega t, and v, which is my d by dt of x of t, in my formula. So my formula was u integration of v minus integration of derivative of u minus integration of v. Now look at here, if this dt get cancelled, so integration will not be applied on x of t. Similarly, if this dt gets cancelled, then integration will not be applied on this whole x of t. So my result is in this last bracket, j omega is a constant term because we are going to integrate this whole equation or integration with respect to t. So I can take this j omega outside this bracket. Now I'll substitute all this value inside this bracket. So first of all, upper limit is substituted first and then later on a lower. So infinity will be placed first and then minus infinity. So both these t is replaced by infinity and minus infinity. Now infinity into anything is always infinity, so I'm going to write here infinity. Now minus, I'll replace this whole t by minus infinity, but minus minus become plus, and infinity into anything is always infinity, and this t is also replaced by infinity, that is minus infinity. Now in the next part, as I said, minus j omega is a constant. I will take it outside, so minus minus become plus, so we'll write plus j omega minus infinity x of t e to the power minus j omega t. But I can say that here this is nothing but the definition of a Fourier transform. So I'm going to replace whole this integration by x of j omega. But what about this? Look at it, e to the power of minus j infinity. Infinity into anything is always infinity. So e to the power minus infinity is always 0. And if this function is causal, then x of minus infinity is also 0. So whole this bracket is considered as 0. So we will get the answer of my plus j omega into x of j omega. My whole exponential term will be replaced by 0, and the next term, the integration is considered as definition of Fourier transform. So I have replaced it by x of j omega, and the j omega is a constant term, and this is nothing but the proof of time differentiation property. So similarly, we are going to prove a next property, that is a frequency definition property, but in next video. But for that, stay tuned to Ekeeda and subscribe to Ekeeda for further more videos. Thank you so much.